Black holes are quite a phenomenon, one that is incredibly difficult to see or capture. As such, they're invisible to our naked eyes and to the prying eyes of X-ray telescopes. However, scientists have gone above and beyond all of these limitations to capture a stunning image of Sagittarius A, the black hole at the center of our very own Milky Way galaxy. But what does this image really show? And what's so unique about it? In simple terms, a black hole is anything but space. It's an extremely dense region of space with so much matter packed into it and a gravitational field so strong that nothing, not even light rays, can escape its grip. For perspective, the amount of matter stuffed into a black hole is comparable to squeezing 10 suns into an area approximately the size of New York City. The basic concept of black holes was first suggested by the great Albert Einstein in his theory of general relativity, which describes how a massive star leaves behind a dense remnant core when it dies. Based on Einstein's explanation, this core would eventually generate a gravity that overwhelms all nearby forces, producing a black hole. Back then, black holes were nothing more than a mere theory. But Einstein's theory would be confirmed many years later when scientists discovered that black holes are formed from massive explosions known as supernovae. A supernova blast occurs when a large star dies. As predicted by Einstein's law of general relativity, this process leaves a stellar core behind. Consequently, if the mass of the star is at least 3 times that of the Sun, it can be proven theoretically that no force can prevent the star from collapsing under the influence of gravity. But as the star collapses, something weird happens. The surface of the star approaches an imaginary surface known as the event horizon. Time stands still, and the star becomes a frozen, collapsing object, as it can no longer collapse. During this process, some stars become super-dense neutron stars or stellar mass black holes. According to the official data, there could be over 100 million black holes hovering around empty space within the Milky Way galaxy, with some of them estimated to be several billions of times heavier than our Sun. Black holes of this size are called supermassive black holes. According to scientists, every galaxy has a supermassive black hole attached to its center, and the Milky Way is not any different. Owing to the stories that have been told about them over the years, black holes have quite a scary reputation, and indeed, they live up to it. As mentioned earlier, nothing within or beyond the universe is strong or fast enough to escape the grasp of a black hole. Hence, anything that comes too close to it, whether it is a star, planet, spacecraft, or human, will be vertically stretched and horizontally squeezed beyond normal proportions in a process known as spaghettification. This absolutely explains why black holes are one of the most feared celestial elements. But ironically, these dreaded elements play an important role in upholding the sanity within our solar system. In fact, it has been discovered that these beasts are just as generous as they are destructive, and without them, our world wouldn't even exist in the first place. For instance, the stellar explosions that produce black holes are also responsible for ejecting essential elements such as carbon, nitrogen, and oxygen into space. Furthermore, the collisions of black holes and neutron stars also help spread heavier elements such as gold and platinum. All of these elements make up our Earth and the human body itself. These elements also make up the air that we breathe and the fuel for rockets that enable humans to explore space. In other words, without black holes, neither Earth nor humans would exist, despite black holes stretching and squeezing everything that comes across their paths. Supermassive black holes are known to trigger the birth of new stars. These black holes eject intergalactic gas onto the edges of their galaxies, which forms gas bubbles. Consequently, new stars are formed when tiny satellite galaxies cross the bubbles. Also, the jet streams released by supermassive black holes clean out the intergalactic way, so that the tiny satellites passing by do not get affected by the supermassive black hole itself. Critically, the black holes in the hearts of galaxies aid the development of our solar system in different ways. To start with, the gravitational pull of black holes tugs on the arms of galaxies, allowing them to run as they should. Additionally, it keeps the stars and other celestial materials within our solar system in their rightful positions. This means gravitation wouldn't exist, and stars cannot form without black holes. Lastly, understanding black holes and the concept behind them is important to explain how the universe works. For example, black holes give researchers better insights into the theory of gravitation, which is important to many of the standard processes on Earth. Interestingly, black holes are incredibly hard to spot. In fact, these beasts are invisible to telescopes that detect X-rays, light, and all other forms of electromagnetic radiation. The only way scientists have been able to confirm their existence is by studying the effects of their gravitational pull on the materials around them. But in a first-of-its-kind event, scientists peered 55 million light-years into the depths of space to capture a fascinating image of M87 star, the black hole at the center of the M87 galaxy. The image of this gluttonous beast shot by the Event Horizon Telescope (EHT) allows scientists to see the sudden loss of photons. The Event Horizon Telescope is an array of 8 ground-based telescopes located across the globe. Expectedly, the image opens a new area of research around black holes because it was our first time seeing these phenomena. Fast forward to 2021, when astronomers revealed an improved view of the black hole, showing what the gigantic M87 star looked like under polarized light. And thanks to the superior orientation and brightness of polarized light as compared to non-polarized light, the new technology showcases the black hole in even more detail. From extensive observations of the image, scientists realized that the black hole's ring is magnetized, which allows them to make well-calculated predictions about some of its other features. More recently, in the spring of 2022, scientists unveiled the image of another black hole much closer to our planet. Located just 26,000 light-years away at the center of the Milky Way galaxy, this black hole, called Sagittarius A star, is a gigantic structure that gives just as much as it takes. But what does the image of the Milky Way's black hole really show? And how did we manage to capture this beauty in the vastness of space? Originally, black holes are said to be pitch dark and invisible, which basically means it should be impossible to capture their picture. But in reality, they're not. In fact, astronomers discovered that rather than being dark, the edge of a black hole is actually very bright due to the swirling particles that generate heat outside the horizons of the hole. The striking image captured by the Event Horizon Telescope shows Sagittarius A as a glowing, donut-shaped ring of light. As shown in the picture, the ring structure called the emission ring is situated just outside the event horizon, which is literally a region of the black hole where light cannot escape. Staring at this elegant image, the bright ring encircles a dark center, which scientists describe as the black hole's shadow. Astronomers believe that based on the dimension of the emission ring, Sagittarius A star is about 4 million times the mass of our Sun. Additionally, the temperature of the white-hot plasma is believed to be between 10 and 18 billion degrees Fahrenheit. Ironically, the image of Sagittarius A star is quite similar to the image of M87 star black hole, perhaps because they're composed of the same materials. However, M87 star is a supergiant compared to Sagittarius A star. For perspective, Sagittarius A star is 16,000 times smaller than M87 star. Due to this huge difference in size, scientists had a difficult time getting a sight of Sagittarius A star. In fact, both objects were observed at the same time, but it took an additional 3 years to create the picture of Sagittarius A. This process involved the extensive international collaboration of hundreds of astronomers, engineers, and computer scientists, as well as the development and implementation of sophisticated computer algorithms, all to produce the first ever real-life image of the black hole at the center of our galaxy. More importantly, it is also one of the most important visual proofs of general relativity, validating the works and predictions of the great Albert Einstein.